So the questions gives a function f and g, each with domain real in the real numbers, are defined by such and such. We have f of x and g of x. Both are very simple graph. For task A, you are to write down the expression for f inverse. This is one of your tasks, one task, and you have to state giving a reason whether G have an inverse. One task and two tasks, and then you'll have 2 marks. Therefore, this is a very straightforward questions, so you don't actually even need to show any workings to find F inverse. So for this, you can double check. Say you send 3 as the object, your image should be 4. So F inverse will reverse it. So from if you are given 4, you should go back to 3. So you can straight away state is F inverse of x is equal to x minus 1. Of course, if you show workings, there's nothing wrong. Now the second task is you have to state, means you straight away give the reasons whether G has an inverse or not. Now when we look at these modulus functions, we know that the modulus curve is like this. You will have 2 parts for your modulus function. Now you have to understand that there's a left hand side and right hand side. This graph on the right hand side is actually y equals to x, while the left hand side is actually y equals to negative x. For x larger than 0 or equals to 0, we'll use this y equals to x, and for x less than 0, you'll use the function y equals to negative x. This is not related to it, but when we know what kind of this graph it is, we know how does a modulus graph looks like, and we can find we can use a horizontal line test. So we can find a horizontal line such that 2 points is touched, meaning we are having a many to one relation. Okay, we are having a many to one relation. So therefore, we do not have an inverse. We does not have an inverse because it is not a one-to-one function. I didn't have time to write it properly. It looks a bit ugly, but yes, in order to have an inverse, you need to be a one-to-one function. Now, second part asks you to sketch the graph y equals to g compose f. So we put f inside g. Therefore, the outcome is y equals to modulus of x plus 1. Now, so the graph is, we know this is very similar to y equals to modulus of x. The difference is the x here inside from x become x plus 1. So what the changes make is it makes the graph move actually from modulus of x move left 1 steps. So you have this so you have 2 marks, and 2 marks will entirely falls on the graphing. Now when we sketch, some students just labeling -1, but the y-axis, the y-intercept here will be very, very important. It is very important because you need 2 points to actually know that this is the gradient of the function is, you see, y equals to x is not y equals to x. In fact, you can note if you want to check y equals to modulus of 2x plus 1, 2x plus 2 probably will give quite the same, the shape will be the same, except that the y-intercept will be different. So you have to be very, very careful that you need to actually label 2 to fix down the point. If the mark scheme will be a little bit strict, then you won't be able to score it, right? Then, well, okay. So now, the marks given will be properly shaped, and then all labeling correctly. Usually, second point with the perfection points, but it will depends on how the marking scheme is done. Okay. Now the third one, the C part C, is the solution set Now you have to be very careful with this word sets. Means you have to write your answer in using set notation. When G composed F is equal to F composed G. Now what is G composed F? Is what we found in 1b, so it's straight away modulo of x plus 1. F composed G means you put the G modulo of x inside x plus this f function, so it will give you modulo of x plus 1. Now we know that modulus of x plus 1 is just a modulus x move upwards one step, okay, by using transformation, the understanding about transformation of graph. Therefore, you have this gray area. You don't have to re-sketch it, but you know it. Okay, they expect you to know it is a very simple graph. And the coincide part will be this part. You know that this part are the one coincide, including when x equals to 0. Therefore, you write your answer as this. Of course, if you write your answer x such that x more than 0, it probably will be accepted in STPM. Right. Now, whether you need to put x in real or not, it depends on your exam board. So you need to check whether your exam board actually requires you to write it. But it will be better if you put x in real. But if you have no confidence, we better leave it out. Now the problem is some students may not realize this. It is a 2 marks question, so obviously 1 marks for the answer. And another mark probably you will have to show that you find what is F composed G. And if you want to do an algebraic method, then you have to break down, as I said before, you have to break down to 2. Now, this is the number line where -1 is the breaking point for x plus 1, okay? For left-hand side, you have x plus 1 in bracket negative, okay? It's the reflections in x-axis. For right-hand side, it will be y equals to x plus 1. So for x minus, over here, you can see x plus 1, when it is when x is less than -1, we use y equals to negative in bracket x plus 1, okay? Now, for modulo of x plus 1, you look at the gray one, okay? The breaking point is 0. So when x equals 0, to the right you use x, to the left you use negative x. So in short, even though we have the same this graph equals to this graph, but for x less than -1, you are actually solving for negative of x plus 1 equals to negative x plus 1. Then when you solve, you find that 1 is equal to -1 and you find contradictions. Contradictions meaning you cannot find any solution. And for between -1 and 0, you have x plus 1, okay, equals to negative x plus 1. Therefore, you'll find at the end x equals 0. So it means x equals 0 is an answer. For x more than 0, you will have, okay, x plus 1 equals to x plus 1, which is exactly the same, means you have infinitely many solutions, means all the x will be accepted. So x more than 0. So concluding these two together, then we will have x more than or equal to 0. So this is how you get the answer.